Good day, everyone. So today we're going to deal with sigma notation from different past papers. So as you can see, now we're starting with the one from 2021 November, question 4.3. So question 4.3, they only asked us to write this in expanded form. And they said we should only show the first three terms and the last term, which is quite easy to do. So usually when we see sigma notation, we always put on the first three terms and the last term. It's actually what we've always been doing. So let's write it in expanded form. So it means n is starting from 1, so it means when I start substituting 1, then we'll substitute 2, then we'll substitute 3, right? That's the first three terms. If we started from -1, we'll first substitute -1, then we'll substitute 0, then we'll substitute 1, right? So let's substitute 1 since it starts at 1. So it means the first three terms is just going to be that plus. We substitute 2 plus. We substitute 3 plus dot dot dot. So we substitute the final one, which is 2 into 5,000 plus 3. And then on the next line, 2 times 1 is 2 plus 3 is 5. And then here, 2 times 2 is 4 plus 3 is 7. I guess the next one will be 9, probably. 2 times 3 is 6 plus 3 is 9. Yes, indeed, it's 9. Plus dot dot dot. 2 times 5,000, which is 10,000, plus 3 is 10,003. Yep, that is it for 4.1. So it was quite easy. 4.3, I mean, it was quite easy, right? So they just asked us to write it in expanded form, and that's what we did. Nothing special, just that. So similarly, if they ask us to evaluate, if they say evaluate, it just means we have to do this first, and then we have to figure out if it's arithmetic or geometric. Then from there we find the sum. And that is it. Every time we see sigma notation, if they say evaluate, we just write down the first three terms and the last term. We use it to figure out if it is arithmetic or geometric. For instance, here it's arithmetic because it has got a common difference, right? And then if we want to evaluate, then we'll find the sum of arithmetic sequence, right? So now, then after that, I dealt with that in the other video. So after that, we'll have to figure out how many terms are they, right? To figure out how many terms are they, it's always top minus bottom plus 1, right? Because yes, we can see there are 5,000 terms, but if it started with -1 instead of 1, there are no more 5,000 terms. It's not even 4,999 terms. Must be careful of that, right? There are actually 5,002 terms. So how? Top minus bottom is going to be 5,000 minus 1. Remember, it's an example of if it started with -1. So minus 1 plus 1. So this becomes 5,000 plus 1, because minus is plus 1, you see? So it's 5,002. Right? So to avoid problems, every time you want to figure out how many number of terms are there in the series, you have to say top minus bottom plus 1, always. And then from there, you can now substitute it into the SN formula. And here it will be 5,002 terms, right? It will be 5,002 terms. So it will be 5,002 terms equals to 5,002 divided by 2 into 2a. You know that stuff, the formula of the arithmetic sequence. I dealt with that in another video. Yeah, so let's go forward. So in the next question, they said, hence, calculate the value of this stuff. Well, when they say hence, it just means you have to use the previous answer to get the next one, or it means the next question is related to the previous question. So in this case, you see this part is related to the previous question. We did already calculate the value of this stuff. So let's continue. When you see two sigma notation stuff adding up, it just means we have to find the sum of this and then find the sum of this and just add them together. Nothing difficult there. So let's find the sum of this. We already did the first step. That's why they're saying hence, because according to the previous question, we got our first term as 5 and the value of the second term is 7, the value of the third term is 9, and we had plus dot 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 plus 10,003. And we did figure out that it was an arithmetic sequence because the common difference was 2. So let's find the sum. So, of course, we know that Sn is equals to n over 2 into 2a plus n minus 1d. Here, the shortcut is to use a plus l, but for the sake of some people, I'm not going to use that. Let me just use this. So let's figure out how many terms are there. So it's always top minus bottom plus 1. So 5,000 minus 1 is 4,999 plus 1 is 5,000 again. So it means 5,000, the sum of 5,000 terms is equals to 5,000 over 2 into 2. Our a is 5 and our n is 5,000 minus 1. Our d is 2. And when you type this in a calculator, you will get this as your value. So we got the first part, right? So the first part was 250200000. That's what we got. So now we need to deal with this the same way. So let's find out. Let's evaluate this, right? So we're just evaluating this, then we have to add them together. Evaluating, when they give you sigma notation and they say evaluate, you just have to find the sum of that. So let's come up with the first 3 terms of that. So we're going to start by substituting 1. So when you substitute 1, we will have 2 into 1 minus 1. Then when we substitute 2, we'll have 2 into negative 2 into 2, minus 1 plus negative 2 into 3 minus 1 plus dot 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 plus negative 2 into what? Negative 2 into 4999 minus 1. And let's continue. So this will become negative 2 minus 1, which is negative 3, plus negative 2, negative 4 minus 1, which is negative 5. And of course, when we see positive and negative, overall it just becomes negative. So we can just put it this way. And then negative, of course, I believe the next one will be negative 7. So, of course, here's negative 3 minus 1 is negative 7. I could write plus negative 7, but plus and minus just makes minus. So I can just write it like this. Similarly, when you see a pattern like this, don't get confused. It just means we're adding negatives. That's why we have this as a result, right? This is exactly the same as this stuff. But we don't need to write it like this. We can just write it like that. And then we have minus, because I know the next one will be a negative value, dot 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 dot, and the final one will be minus what? So 2 times 4999 will give you 9998, right? So that's the value of the final term. Okay, 2 times, okay, it's not the value of the final term. We have to minus 9, minus 1, then it will become 9999, because 2 times this stuff is 9998, and then minus 1 is 9999. All right, so we have that. So we have got 4 nines there. And then let's figure out if it's arithmetic or geometric. Of course, it's obviously arithmetic. This will be a minus 2 there, so minus 2. So now let's find the sum of the terms. So how many terms are there? Top minus bottom plus 1. It will still be the same because it starts from 1. If it doesn't start from 1, it will definitely be different. So the sum of the terms is 4999, right? Not the sum of the terms, the total number of terms. So now we have 4999 divided by 2 into our a. So our 2a, which is 2 times negative 3 plus 4999 minus 1 times our common difference, which is negative 2. So when you type this in the calculator, we will get minus 24,99999. So that's what we have. So it means here we'll say plus minus, but there's no need to do that. We can just say minus 24,99999. All right, so that's what we have there. And then now all we have to do is just to subtract these two. Yes, we're adding them, but of course we're adding a negative. That's why it became subtraction. So when we subtract the 2, this is what we'll get. 20,001. So that's what we have. So that brings us to the end of this past paper. All right, let's go to the next one. Now we move on to 2021 June. So they said consider the geometric sequence where the sum to infinity gives you 27 and the sum of the first 3 terms is equal to 26. Then they say calculate the value of r. In this case, we have to use simultaneous equations. So we know that the sum, how do I know it's the sum to infinity? Sigma means sum, right? And of course the final is infinity, so it's obviously the sum to infinity. We know it's equals to a over 1 minus r. So our sum to infinity is given. This is not the value of the last term. By all means, whenever you see sigma notation equals to something, then it means this is the sum. So it means 27 is equals to, we of course don't know our a, 1 minus r, which is what we're looking for. So you see, we're going to use simultaneous equation. Both our a and our r are not known. And let me form the second equation using this stuff. So the sum of the first three terms will give me 26. And because this is a geometric sequence, we know that Sn is equals to a into r to the power of n minus 1 all over r minus 1. And it's quite simple. The sum of the first three terms is equals to 26, right? So it means what? It means that 26 is equals to our a, which is what we don't know, over into r to the power of 3 minus 1 all over r minus 1. So this is not difficult. This is quite easy. Here I can actually factorize using the difference of two cubes, if you look at it, so that we can get rid of the r at the bottom. But if that's going to confuse you, I'm going to just leave it like this. But either ways, let me just leave it like this. So this is going to be our equation 1. This is going to be our equation 2. And then now we form our equation 3. Let's form our equation first. Let's form our equation 3. So I want to make a the subject of formula. So it's this 27 is the same as 27 over 1. So 1 times a is just a. And then 27 times this stuff is 27 into 1 minus r. So there, I actually did make it the subject of formula. So now this is going to be my equation 3. So now let me substitute equation 3 into equation 2. So it means in equation 2, wherever I see a, I just replace it with this stuff. So let me do that. So then that will become 26 is equals to 27 into 1 minus r. See, in place of a, I'm just doing that. And then this becomes r cubed minus 1 all over 1 minus r minus 1. All right, and there is, by all means, nothing difficult here. So from there, it becomes 26. So now here, I want to cancel out, right? I want to try and cancel this. I can factorize this using the difference of two cubes. I'm going to put the video of that in the description. Let me solve it using two ways. I'm going to solve it using two ways so that you can see that this is really easy stuff. So first, I'm going to solve it by factorizing using a difference of two cubes, and I'll show you another way of solving this thing. So this is going to become this stuff. When you factorize the difference of two cubes, you just put down the cubes down, and of course I'll put it in the link of the description. In the description below, I'll put the link of factorizing difference of two cubes just in case you forgot. So this becomes r squared plus r and plus 1. Okay, I hope you don't mind my handwriting just due to space. And you see, these two stuff can cancel. And then now we'll be left with 26 is equals to 27. And then we're going to have into 1 minus r. Then here we have r squared plus r plus 1. And from here, let me just divide both sides by 27. So that I can have 26 over 27. There's many ways to solve this. And then let me just distribute the 1. So this is going to become r squared plus r plus 1. Then let me distribute this one, so it becomes minus r cubed minus r squared minus r. And here's the beautiful thing. This and this cancels out. This and that cancels out. So what are we left with? We're left with 26 over 27 is equals to, well, the ones didn't cancel out, of course, because there's no other one. So we have 1 minus r cubed. And from here, what can we do? Well, let me take this to this side so that it can become positive. Let me take this to this side so it becomes 1 minus 26 over 27. And of course, this becomes r cubed is equals to this should become 1 over 27, and then of course we just have to find the cube root of that. So by cube rooting both sides, and of course when we cube root both sides, r becomes 1 over 3. And there we found the common ratio. If they asked us to find the first 3 terms, we would have substituted this into the other equation to find a. Remember, it was simultaneous equations. Easy stuff. And I wanted to use the other way to solve it, but due to time I'll just leave it like that. Alright, so let's move on. Alright, so I'll move on in the next video, right? So in the next video I'll be dealing with 2020 November and June exam and sigma notation. So here in I dealt with November and June 2021. Next video I deal with 2020 June and 2020 June and November, right? And don't forget to subscribe so that you can receive more videos, right? Subscribe to my channel, and don't forget to like the video. And of course, any questions you've got or any suggestions, please comment. You're more than welcome. See you guys on the next video.